All right, even and odd functions. So a function is considered even if you have a graph of a function that is symmetric about the y-axis. And the way that we're going to determine that is we are going to say if f of negative x is the same as f of x. So, if we look at, for this function, f of 2 and f of negative 2, we get the same value, right? So that's saying f of negative 2 is the same as f of 2. If that's the case, you have an even function, again, and it will be symmetric about the y-axis. If negative x, f of negative x is equal to negative f of x, then you have what's considered to be an odd function. So here we're looking at maybe f of 1 and then f of negative 1. And so what this is saying is the y value at 1, the y value at negative 1 is negative what the y value was at positive 1. Right? So f of negative 1 is equal to negative the f value of 1. And so we get something that's symmetric about the origin. So it's kind of flipped both across and down from where that original point was. Okay? So when we look at a function, the way we're going to do this is we're going to test these things by doing f of negative x. If we end up with the original function, it's going to be even. If we end up with negative the original function, it's going to be odd. And if neither one of those things happens, then it's neither even nor odd. So here's my first example. I'm going to do f of negative x. And what that means is I'm going to go through and replace every x with negative x. And I'm going to work this out. So negative x to the fifth. Well, if I take a negative to the fifth power, that would give me a negative. So I would still have negative, and then I would have x to the fifth power. And then plus negative x, I can just call that minus x. And so as you can see, we didn't get the original function. We did not get x to the fifth plus x. We got negative x to the fifth minus x. So if I don't get the original function, I'm going to factor out a negative and see if I have negative the original function. So if I just factor out a negative from both terms, I get to the original function here of x to the fifth plus x. So because f of negative x is equal to negative f of x, this function is odd. Next one, I'm going to do g of negative x. So that's going to give us 1 minus negative x to the fourth. Again, I'm just replacing x with negative x. Okay, if we take a negative 1 to the fourth power, that's going to turn to positive 1, and then I'm going to have x to the fourth. So that's going to just be positive x to the fourth, but I still have this minus here. Okay, so I ended up with 1 minus x to the fourth, which is the same thing as we got here. So g of negative x is the same thing as g of x, and therefore this function is even. And the last one, if we're going to do h of negative x, we're going to get 2 times negative x minus negative x squared. So 2 times negative x is going to be negative 2x minus, if I square that negative 1, that will turn positive, x squared. So I didn't get the original function. So because of that, I don't have this exact same thing. I'm going to factor out a negative and see if I end up with negative that whole thing. If I factor out a negative, I get negative times 2x plus x squared, which again is not equal to the original function. And because I don't have either one of those things happening, this would be neither even